Greetings students, let us discuss some instruments in our physics laboratory. In earlier classes, you have studied the measurement of length by the different instruments. Many times you have used this kind of scale for drawing purpose, to draw 5 centimeter length, to draw 7 centimeter length, and suppose you have to measure the length and breadth of this box. What you have to do? You keep the 0 point at the initial and up to the final value, you measure the length of this box. But we have different more instruments with us, more different kind of bodies with us. Suppose this is a spherical ball and you have to find the diameter of this ball. Now using this scale, the diameter of this bulb cannot be measured because there will be some error. Or if I tell you to find the diameter of this cross section of this cylindrical body or the length of this cylindrical body, so some error is caused by the measurement of this scale. Now we cannot use the scale to find the diameter of this bulb or to find the diameter of this spherical surface, or suppose you have to find the diameter of this wire. You cannot find, this cross section is very small, so you cannot find the diameter of this wire with the help of this scale. For the measurement of the diameter, let us introduce with a new instrument that is known as the Vernier Caliper. This is the instrument with the help of which we can calculate the diameter of this bulb, the outer diameter, the diameter of this cylindrical body. This Vernier caliper have different parts. Let us discuss the different parts of this Vernier caliper. This is the instrument named as Vernier Callipers. Now the different parts of this Vernier Callipers are, I am moving this Vernier caliper. Let us first look here. This is the main scale of the Vernier caliper, whose upper readings are in inches and the lower readings are in centimeters. This is 0 to 1 centimeter, then 1 to 2 centimeter, and this main scale is fixed with a jaw, that is the lower jaw, and this is the upper jaw. Now this sliding scale is visible to you. This is the sliding scale. The sliding scale is known as the Vernier scale. And if I am moving this Vernier scale, you can see that another jaws appear to you. This is the another lower jaw and this is the upper jaw. These lower jaws are used to find the outer diameter of any object. Suppose this cylindrical body, and you have to find the diameter of this cylindrical body, the outer diameter of this cylindrical body, and this is known as the lower jaws. This part is lower jaws of the Vernier caliper, and these upper jaws are used to find the inner diameter of any object. Suppose we have to find the inner diameter of the beaker or the inner diameter of this instrument, then what we have to do? We have to keep the jaws inside the object whose inner diameter is to be measured, and this we note down these readings for the inner diameter. So upper jaws are used for measuring the inner diameter. And now the back side of the Vernier caliper. This back side is fixed with a rod, and if we move the vernier scale, this rod is moving, and this part of the rod is used to measure the depth of any instrument. Suppose we are measuring the depth of any beaker any device, we keep this inside the beaker and we measure the depth, and the reading is on the main scale as well as on the vernier scale. Now let us discuss first about the error. What is the error in the instrument? How we use the error in the calculations. If the zero of the main scale, this zero of the main scale is exactly coinciding with the zero of the vernier scale. Is it visible to you? The zero of the main scale is coinciding with the zero of the vernier scale. It means there is no error in the instrument. But if initially the instrument is having the some digits, that the 0 point of vernier scale is not coinciding with the 0 of the main scale. Here you can see that this 0 of the vernier scale is not coinciding with the 0 of the main scale. It means there is some error in the instrument. I will explain the error with chalk and duster on the board, because these readings are not so much clear in the picture to you. And if I keep the instrument here, keep the spherical body in the jaws of the vernier caliper, this measures the diameter. Now how you will measure the main scale reading and the vernier scale reading? First of all, this is your main scale, this is your main scale, and this is your vernier scale. The main scale is having 10 divisions between 0 and 1, 1 and 2, and similar on the different scale. Let me explain again. The main scale is having 10 divisions between 0 to 1, it means 1 division is equal to 1 mm, because this is 1 centimeter. But the vernier scale, this vernier scale has 9 divisions. Here it has 9 divisions, and these 9 divisions are equal to the 10 divisions on the vernier scale, these 9 divisions. So this vernier scale has a difference of one value, and that is 0.1. If we check the complete 1 centimeter value, then we find that this vernier scale, the one division of this vernier scale, because one division is 0.1, 0.1, 0.1, these 9 division, when it travels, then the difference of 0.9 mm takes place. It means the one division of the vernier scale has the value 0.9 mm, but the one division of the main scale have the value 1 mm. So this difference of the readings give us the least count of the vernier calipers. Now how you will read the readings here? How the reading you will read the reading? You keep the object in the jaws for measuring the outer diameter. You will keep the object like this. Hold it in your hands gently and check where the 0 of the vernier scale is coinciding with the which value of the main scale. This is 1, and the 0 of the vernier scale is coinciding with the third reading. It means the main scale is 1.3. The main scale is 1.3, 1 centimeter, and 0.3 is 4 mm. This is your main scale, 1.3 centimeter. And the vernier scale reading, how you will read the vernier scale reading? There are 9 divisions on the vernier scale. The division which makes the straight line with the main scale division, any line which makes a very straight line with the main scale, that division is our vernier scale reading. So let us check our, and you have to observe the reading exactly normally from the instrument. if it is visible to you, the eighth reading, the eighth division of the Vernier scale is coinciding exactly with the main scale. So the Vernier scale reading is 8. It will be from 0 to 9. The Vernier scale reading is 8 and main scale reading is this. Main scale reading is 1.3 and Vernier scale reading is 8. Now you can repeat the experiment 3 or 4 times to eliminate the errors. Now let us discuss how you can solve or you can calculate the diameter of this bob mathematically. Now what is the aim of our experiment? To find the diameter of a spherical or cylindrical body using Vernier calipers. What is the material required for there? The Vernier caliper and the object whose diameter is to be measured. So first of all, we need to find the least count of the Vernier caliper. As I have told you, there was one main scale attached with the one jaw, and in that case 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This was 1 and this was 0. But on the Vernier scale, this was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The 10 divisions on the Vernier scale is equal to the 9 divisions on the main scale. So we have to write the 10 divisions. If you watch the instrument carefully, the 10 divisions on the Vernier scale are equal to the 9 divisions on the main scale. And on the main scale, 1 division is equal to 1 mm. So you can write that 10 division are equal to 9 mm. If you calculate the 1 division of Vernier scale, that is equal to 9 by 10 of MSD, and main scale division is equal to 1 mm, 1 division. So you can write it as 9 by 10 mm or 0.9 mm. So you can write the 1 main scale division is equal to 1 mm. The 1 Vernier scale division is equal to 0.9 mm. And what is the least count? Least count is the least value, the minimum value on the scale which we can read, and that minimum value is the difference of the main scale division and the Vernier scale division. So this is 1 minus 9 by 10, 1 by 10 mm, or you can have it 0.1 mm you can write, or 0.1 centimeter. So you can write the least count is equal to 0.01 centimeter. If this is visible to you, you can see here these are the 10 divisions 0 to 1, and these 10 divisions, if you coincide 0 of both these scales, then what you are observing that the 10 divisions on the Vernier scale, the lower scale is the Vernier scale, is equal to the 9 divisions on the main scale. When you keep the object in between the jaws, what you observe? This 0 of the Vernier scale is shifted from the main scale, and this value I have shown you, this value on the main scale, the 0, where the 0 of Vernier scale coincide with the main scale, that value is 1.3. So write the main scale reading in this column, that is 1.3. This is in centimeters because the main scale is in centimeter. This is 1.3 centimeter. Now the Vernier scale reading, how you will observe the Vernier scale reading? You have this kind of values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your main scale, and if the Vernier scale divisions are like this, out of these readings, the one division you will find, and that division will coincide with the division of main scale. This is 0, 1, 2, 3, 4, 5, 6. So your Vernier scale, this lower scale is Vernier scale and the upper scale is main scale. So this division is your Vernier scale reading, and when I have shown you, this was the 8th reading. It was represented by N. And how you will take the total reading? The total reading will be the main scale value. Main scale value is 1.3 plus. You cannot add the Vernier scale directly in the main scale because the values on the Vernier scale are in millimeters. So you will multiply by the least count. There is a difference between these two scales. So Vernier scale reading was 8 and the least count is in, this was in centimeter. So you have to take the least count of centimeter units. This is 0. The total reading will be the sum of main scale reading plus Vernier scale reading into least count. Main scale is 1.3 given to you. The Vernier scale is 8 and the least count in centimeters is 0.01. So this is 1.3 plus 0.08. The total value is 1.38 and the units are written here. You will repeat the experiment 3 times and then you will calculate the mean diameter. The mean value, this total reading is the diameter, you can say this is the diameter. So mean diameter is the mean of, suppose these are 3 values x, y and z, you will have x plus y plus z divided by 3 into centimeters. Keep in mind that your decimal should be up to 2 decimal places because the least count is having 2 decimal place. While converting this mean, keep in mind that it should be rounded off up to 2 decimal places. Here one main point is also there, that you have to calculate now the error. What do you mean by the error in the instrument? If the main scale and 0 of the main scale and the 0 of the Vernier scale both are coinciding with each other, in that case the 0 error is nil. So in our instrument, what I have shown to you, the 0 error is nil. But in some cases, this may happen that the 0 of the Vernier scale is not coinciding with the 0 of the main scale. It is shifted towards right hand side. It means this is measuring some distance before your observation. It means this is the extra value which the main scale is having. So you have to, if the Vernier 0 of the Vernier scale is on the right hand side and this value is extra, this type of error is known as the positive error. This is towards the positive side scale of the measurement. This error is known as positive error, and this error should be subtracted. This error should be subtracted from your result. So this is known as zero correction, and zero correction is, if the error is positive, you have to subtract it from the result from your measurement. But if there is the another situation when the 0 of the main scale is not coinciding with the 0 of Vernier scale, this is main scale, this is Vernier scale, and your Vernier scale is towards the left and it is measuring less distance, and this distance should be added to your main scale reading. So this type of error is known as the negative error, which is towards the negative axis of the scale, and for the zero correction, this zero error should be added. This point is very important and you should note down this point for the observation as well. First, before starting the reading, before starting the observations, you have to check the zero error of the instrument. If zero error is positive, in zero correction, it should be subtracted. If zero error is negative, in the zero correction, it should be added, and this is all about the diameter of the spherical or cylindrical object by using the vernier caliper.